Okay, hello everyone. In this video, we are going to discuss about inverse Laplace transform using partial fraction. In our last class, we have been discussed about inverse Laplace transform by convolution. In detail, we have been discussed. Few numericals also we have been solved. I given one or two questions that you have to solve by yourself. This question and these two questions. Okay, so hopefully you have been solved those questions. And now in our today class, we are going to discuss inverse Laplace transform using partial fraction. Okay, so let's start. In this topic, actually, maybe question will be induced in our mind where the partial fraction is required to solve the inverse Laplace transform numericals. To understand properly, let us consider a non-homogeneous differential equation like this. This is your second order non-homogeneous differential equation d square y by dt square plus 2 into dy by dt plus 5y equal to e to the power minus t into sin t, where initial value conditions given that y0 equal to 0, y dash 0 equal to 1. Suppose in this question it is asked to solve the above differential equation. Okay, so this can also be written as y double dash, and this can be written as 2y dash plus 5y equal to e to the minus t sin t. How we are going to solve it? By using Laplace transform equation, what we are going to discuss in our next class. Okay, so here you can see that Laplace transform of this one, if I am going to take the Laplace transform both the side, then Laplace transform of this one will be equal Laplace transform of this one. Laplace transform of second derivative is nothing but a square Laplace transform of y minus s y0 minus y dash 0. Already we have been studied these things. May you remember initially Laplace transform of derivative. You can check your note. Laplace transform of derivative, this one. For the second one, for the second derivative, Laplace transform of second derivative, a square f of s, or f of s is nothing but Laplace transform of f of t. Also we can write is f of 0 minus f dash 0. Here capital F means Laplace transform of f of t, whatever written over here. Instead of f, here we written as y. So a square Laplace transform of y minus s y0 minus y dash 0 plus Laplace transform of first derivative of a function is nothing but s Laplace transform of that function y minus y0 y at t equal to 0. Okay, as it is differentiated with t, so y t equal to 0, y t equal to 0, that means y0, y in bracket 0. Okay, plus 5 Laplace transform of y will be equal to this much. Laplace transform of e to the minus t into sin t is nothing but 1 by s plus 1 whole square plus 1 square, whatever written over here. And if we consider Laplace transform of y as y bar, here you can put a square y bar here. Here you can say 2s y bar, then 5 y bar. Okay, here minus s y0 given as 0, so that this term will be cancelled out. Y dash 0 is 1, here this value will be 1. So here a square Laplace transform of y, this value will be minus 1 plus 2 into this term, that is your 2s y bar, and y0 is given as 0. Okay, so hence this term will be cancelled out. 5 Laplace transform of y means 5 y bar equal to this much. Okay, so that implies y bar whole into a square plus 2s plus 5 equal to 1 plus this minus 1 taken this side, 1 plus this one will be this one, a square plus 2s plus 3 by a square plus 2s plus 2, or y bar will be equal to how much? A square plus 2s plus 3 whole divided by this term, that is your a square plus 2s plus 2 into this term, a square plus 2s plus 5. At this type of situation, we need the partial fraction to separate with two terms. So here, if I am going to consider this is your PS and this is your QS term, then at this situation we need the partial fraction. So in detail here, both PS and QS are polynomials. What we saw of the function S, it is also well known that when PS degree less than equal to QS degree, here PS degree is 2, QS degree is a square is there, so s to the power 4 will be there. So here for this situation, QS degree is greater, but if QS degree equal to or greater than the PS degree, then this one can be rewritten by using partial fraction. So here we discussed four type of situation where we can use the partial fraction in four type of method. In detail, we have to discuss, and each and every type we have to solve one or two numericals. Okay, here question and answer belongs to type 1, then question and answer belongs to type 2, question and answer belongs to type 3 and type 4 also. Okay, so first we have to just discuss that what type of type 1 situation when QS is non-repeated. That means like this type of situation, a by s minus a, that means non-repeated linear factor. See here this is a non-repeated, this factor both are different. That means non-repeated quadratic factor. If linear factor will be there, means there is no quadratic factor. Suppose s plus 2 is there, so that can be written as simply a by s minus a. If s minus a is the QS, then that will be written as simply a by s minus a. Suppose the denominator, that is your QS will be repeated linear factor. See, in this type of format, s minus a to the power r. Then for the partial fraction, for this kind of situation, it will be written as a1 s minus a plus a2 by s minus a whole square plus a3 by s minus a whole cube, so on, ar by s minus a to the power r. Then we are going to solve and we are going to find out a1, a2, a3 and ar. How we are going to solve that, whenever we are going to discuss the numericals, you will be clear. Okay, in type 3 situation, QS is a non-repeated quadratic. Quadratic means like this, a square plus as plus b, like this. If a quadratic situation will be there, then the numerator will be written as as plus b format. Here a1, a2, a3 are all are constants, but here it will be written in this format, that as plus b by this factor. But in case of type 4 situation, if QS is a quadratic as well as repeated up to r factor, suppose this quadratic term have some power, then it will be partial fraction as a1s plus b1 by this one plus like this square q up to r, a2s plus b2 by this one square up to ars plus br by a square plus as plus b to the power r. No, do not be worry, we are going to solve one and two questions for each type. Okay, then you will be clear at the time. Now consider previous problem. Previous problem means here this problem, that a square, this is there, that at the denominator two non-repeated quadratic terms are there, two non-repeated, this is different and this is different. So to solve this, whenever we are going to consider the partial fraction, then we have to write as plus b by one term plus cs plus d. See here, a1, b1, a2, b2, ar, br all are the constants. So instead of a2, b2, we can write c, d, and then a3, b3 can be written as e and f, so on. Okay, so here instead of a1, b1 we written ab, instead of a2, b2 we have been written c and D. So as plus b by a square plus 2s plus 2, cs plus d by a square plus 2s plus 5. Then whenever we are going to be add these two terms, then this factor will be multiplied with this one, and this factor will be multiplied with this one whole divided by this one. So if I am going to compare LHS and RHS, we can find the denominator, both the denominator are same, therefore the numerator has to be same. That means this one should be this one. Then we have to multiply, and we are going to solve by equating the coefficient of a square, s and constant, and then we are going to find out the constants, and here we have to put, and then two term we can found. Then we are going to go for the inverse Laplace transform. So this is the general procedure that we have to follow. Now we are going to go for type 1 numerical. Okay, example, two examples here I have been considered, that two examples we have to two numericals we are going to discuss. Okay, so the question is that find inverse Laplace transform of 1 by s plus a into s plus b. Okay, now we have to consider partial fraction of this one. So as I told that in case of type 1, we have to write like this. See, here one term is there, means 1 by s minus a. Suppose two terms will be there means s minus a and s minus b, as like this. Here s plus a, s plus b is there. So we have to write a by s plus a plus b by s plus b. Suppose we have another question like this, that 1 by s minus 1, s minus s plus 2, s plus 3, like this. So how we are going to consider the partial fraction? Then like this, a by s minus 1 plus b by s plus 2 plus c by s plus 3. Then we have to solve it, and we are going to find out the constants. How to solve? Here you just watch. So a by s plus a plus b by s plus b, you just add it, a into s plus b plus b into s plus a, right? So here you can see that as, here bs, if I will take the common s, then a plus b we can found, ab plus ba is the constant divided by s plus a into s plus b. Now here we have to equate the coefficient of s to the power 1, and this term is your s to the power 0 term. S to the power 0 means 1. So we have to equating the coefficient of s and equating the coefficient of s to the power 0. So here s to the power 0 means 1. Okay, because the denominator of LHS RHS is same, that means numerator has to same. So here the coefficient of s is your a plus b. This side there is no s term is there, so a plus b will be equal to 0. There is no s term, hence the coefficient will be 0. Here this is a constant, ab plus ba, coefficient of s to the power 0. So here s to the power 0 coefficient means this is 1. 1 is your constant. So ab plus ba equal to 1. Okay, so you can write this one, this constant into s to the power 0, or no need to write. Okay. Now here we found a plus b equal to 0, ab plus ba equal to 1. Now we are going to solve it. We have to find out, we can found a and b value. Here from this equation, a equal to minus b. If I will put a equal to minus b over here, then minus b into b plus b into a equal to 1. So here take common b, so it will be a minus b equal to 1, b equal to 1 by a minus b. Therefore a will be equal to, as your minus b, so minus 1 by a minus b. So we found a equal to this much, sorry, b equal to this much, and a equal to this much. Now we have to substitute over here and here the values, two values, a and b values. So 1 by s plus a into s minus b equal to a value is your minus 1 by a minus b into 1 by s plus a. 1 by s plus a plus b by s plus b. B is your 1 by a minus b into 1 by s plus b. Now we have to take inverse Laplace transform both the side. Take inverse Laplace transform both side. Both side we get what we can get. So inverse Laplace transform of this one, what we intend to find out, is equal to 1 by a minus b, 1 by a minus b taken outside. So this term will be positive, written first, and this term is negative, this written second. So inverse Laplace transform of 1 by s plus b minus inverse Laplace transform of 1 by s plus a. Right. So inverse Laplace transform of this one will be inverse Laplace transform of 1 by s minus b is nothing but e to the power minus bt. So here you can see a inverse Laplace transform of e to the power inverse Laplace transform of 1 by s minus a equal to e to the power a t. So here it is uh, s minus of minus b, so obviously it will be e to the minus bt, and here this will be s minus of minus a, s minus a e to the power at. So here s minus of minus a, so it will be e to the minus at, right? So finally we found the answer is 1 by a minus b into e to the minus bt minus e to the power minus at. Okay. This question already we have been solved by using convolution theorem. Here you can see in our last class we have been solved this question by considering convolution theorem. 1 by s plus a into s plus b, the same answer we got, same answer. So here I suggest to one thing, that you just practice which way you feel that it will be easy, you just answer in that way. Okay, so by two method you can solve this question, this particular question, by this one and by using convolution. Okay, so in which way you feel easy, you just adopt that way. Next question is your inverse Laplace transform of 1 by s into s plus a. This is type 1 question. That means here 1 by s minus 0 into s plus a is there. So what, how we are going to do the partial fraction? This will be a by s plus b by s plus a. You just add it, a into s plus a plus bs by s into s plus a. Here the denominator are same, so obviously numerator we are going to equate the coefficient. Here uh, s term is not there, so b will be equal to 0, b will be equal to 0, sorry, here as a will be one term plus bs. So if I'll take common s, a plus b plus a, so here s term is not there. If I will compare this LHS and this LHS, s term is not there, so a plus b coefficient will be equal to 0, hence b equal to minus a, b equal to minus a. So here you can get that a, this constant is nothing but 1, a equal to 1, so a value will be 1 by a. So here b equal to minus a, that means b equal to minus 1 by a. Now we are going to substitute this a and b value over here and here. What we can write? We can write as 1, we have to substitute, and we are going to consider the inverse Laplace transform. Substitute the value and inverse Laplace transform we consider at a time here. So inverse Laplace transform of left hand side 1 by s into s plus a equal to inverse Laplace transform of here a by s. A we got how much? 1 by a. B we got minus 1 by a. So here if you have to put, it will be 1 by a into 1 by s, 1 by a into 1 by s plus inverse Laplace transform of b means minus 1 by a into 1 by s plus a. So 1 by is the constant. Inverse Laplace transform of 1 by s is nothing but 1. We know that this you have to remember, I told that this 16 formulas or functions inverse Laplace transform basics, you should remember. Here you can see that inverse Laplace transform of 1 by s. 1 by s. 1 by s means s to the power 1 is there. If we are going to consider s to the power 1, s to the power 1 means t to the power 1 will be. Okay, sorry. S here you can see n factorial by s to the power n plus 1. So uh, here it is 1 by s is there. So 1 by s to the power 1 can be written as 0 plus 1, right? So here if 0 plus 1, so it will be t to the power 0. T to the power 0, and this will be 0 factorial 1 is already is there. So n means here n is your 1. So 1 by s inverse Laplace transform will be 1 by s plus a. As we discussed that 1 by s minus a inverse Laplace transform is your e to the minus at. This is written as s minus of a minus a, so e to the minus at. No need to write here. So we found the answer is this one. Okay. Now we are going to go for another question, that 3s by s square plus 2s minus 8. So if I am going to solve it somewhat, then we can found 3s by s plus 4 into s minus 2. The quadratic term, whatever we have the denominator, then this quadratic term can be written as s plus 4 into s plus s minus 2. Now we are going to apply the partial fraction on this. That implies 3s by s plus 4 into s minus 2 will be can be written as a by s plus 4 plus b by s minus 2, and we are going to find out the a and b values. Just add it and we can find s plus 4 into s minus 2 in the denominator, and if I am going to multiply a into s minus 2, it will be as minus 2a plus bs plus 4b. So s term if I will write together, then a plus b into s plus this is your minus 2a plus 4b. Just compare the numerators. Denominator is same, so hence coefficient of the numerator has to same. So here a plus b into s, here 3s, that means a plus b will be equal to 3. If I will compare the coefficient, then this is a constant. There is no constant term on the numerator in your LHS, so this constant term will be 0. So here from this we can find a equal to minus 2b, right? A equal to minus 2b. Now here you can see, if I will be put a equal to minus 2b over here, this will be 2b plus b equal to 3. That means 3b equal to 3, b equal to 1. If I will put b 1 over here, then a we found 2. Now we just put a value and b value over here. Okay, a value is your 2. We just substituted and taken the inverse Laplace transform. Okay, substituted a and b value, you can write over here, substitute a and b value above and take the inverse Laplace transform. So inverse Laplace transform of LHS is equal to, here instead of a we have to put 2 into inverse Laplace transform of 1 by s plus 4, then plus here b means 1 into inverse Laplace transform of 1 by s minus 2. So here this is nothing but s minus of a minus 4. We know that s minus of a is nothing but e to the power at, so it will be a is your minus 4. So 2 already is there into e to the minus 4t will be the answer of inverse Laplace transform of 1 by s plus 4. Likewise 1 by s minus 2 inverse Laplace transform will be e to the power 2t. So this will be the answer. So in this way we can solve the type 1 type of numericals by using partial fraction, right? Here one thing I can I want to recall you that inverse Laplace transform of 1 by s into s plus a already we have been solved by using this one, Laplace transform of integrals, inverse Laplace transform of integrals. We got also the same answer. So I told that in which way you feel easy to solve, you just consider that way. Okay, so two way you can solve. either this one or that one. Okay, now we are going to go for type 2 questions and how to solve it using partial fraction. Okay, the question is the question is find the inverse Laplace transform of a square by s plus 2 whole cube. So here you can see that consider partial fraction. Now we are going to go for the partial fraction of a square by s plus 2 whole cube considering type 2. In case of type 2, here you can see that linear, this is a linear fact, linear but repeated. Here repetition is your three types three times of repetition. S minus 2 to the power 3 times of repetition. How we have to write it? That is your a by s minus a, then another constant, suppose b by s minus a square, then c by s minus a cube. Like this we have to write first by considering partial fraction of this one, a by s minus 2 plus b by s minus 2 square plus c by s minus 2 cube. Now we have to just add these three terms. Then what we can found? In the denominator we found s minus 2 whole cube, and here s minus 2 is there, so a into s minus 2 square plus s minus 2 square is there, so b into s minus 2 plus here s minus 2 whole cube. That means it will be only c. You just consider the square of whole square of s minus 2 square. That means a square minus 2s plus 4, and again multiply a, so a square written over here. Then this 2 square means 4a, then 2 into 2s, 4s into a minus 4as. Then this is your bs minus 2b plus c. As denominator, both the denominators are equal, hence numerator has to equal. So only for that here written. Now equating the coefficient of LHS and RHS, coefficient of coefficients of numerator. Here we have to write numerator, coefficients of numerator, coefficient of numerators, coefficient of numerators of LHS and RHS we found. So coefficient of numerators means here coefficient of a square, s, and this constant. Okay, so if I am going to compare a square and its coefficient is your a, here a square is your coefficient is 1, so we can write a equal to 1. So here s coefficient is minus 4a plus b. So comparing LHS, there is no such term is there. So s coefficient will be, if I will compare, then minus 4a plus b will be equal to 0, because that type of term is absent in your LHS, numerator of LHS. And this one is a fully constant, 4a minus 2b plus c. There is no constant in your numerator of LHS, so 4a minus 2b plus c will be 0. Now we have to solve these three simple questions, three simple equations. So here a is 1, if I will put it, b will be 4, and then if I will put a value and b value over here, then we can get c equal to 4. So now we have to substitute simply a, b, and c value over here. Okay, hence a square by s minus 2 whole cube, that means this one will be a is your 1, b is your 4, and c is also your 4, just I even written. Now take the inverse Laplace transform both this side and this side. Inverse Laplace transform this one, what we intend to find out. Inverse Laplace transform of this term, and this term. Okay, so this is s minus 2, that means e to the minus 2t. Here 4 constant, inverse Laplace transform of s minus 2 square. S minus 2 square means using fast shifting theorem, this will be t and e to the 2t. Already we know it. Okay, already we know very well by using fast shifting theorem this one. That means if f of s minus a will be there, it will e to the power 80 and f of t. So if we are going to consider this one, this is your 1 by s minus 2 square. If it is 1 by s square is there, then the answer will be only t. Inverse Laplace transform, see, inverse Laplace transform of 1 by a square is nothing but only t. But as it is s minus 2 is there, so it will be e to the power 2t into t. according to fast shifting theorem. Likewise here s minus 2q is there, so only for 1 by sq the answer will be t square, but as it is s minus 2 is there, so it will be e to the power 2t multiplied with t square. So by using inverse Laplace transform of fast shifting theorem also I written. Okay, so this will be the answer. Next question for type uh, type 2. Okay, second question that find inverse Laplace transform of 1 by s plus 2 to the power 5. This question already we have been solved here by considering this one shifting property, right? Fast shifting property. By considering fast shifting property or theorem, this question already we have been solved. We found this one. So as we found a factor, a linear factor, repeated linear factor, that means we can consider as the partial fraction. So if we are going to consider the partial fraction of this one, this can be written as a by s plus 2, b by s plus square plus c by s plus 2q plus d by s plus 2 4 plus e by s plus 2 5. So if I will solve it, we can found a, b, c, d all are will be 0 and e will be 1. Here simply I solve, because if I will solve it, it is so large. Here you can see, if suppose 1 by s plus 2 square will be there, then if I will solve it, see a into s plus 2 into b by s plus 2 square. So here you can see as plus 2a plus b will be there. So as, that means a, there is no s term is there in the numerator, so a will be 0. If a will be 0, b will be only 1. Now we are going to consider s plus 2q, 1 by s plus 2q, that means considering partial fraction, a by s plus 2, b by s plus 2 square plus c by s plus 2 q. So this will be a into s plus 2 square plus b into s plus 2 plus c by s plus 2 whole cube. So if I will be solve this numerator, we can found this one. So here you can see there is no a square term is there, so a will be 0. Okay, a will be 0, and then here you can see there is a star, this is 2a plus b, so 2a plus b also will be 0. There is no s term will be there in the numerator, so coefficient here 2a plus b also will be 0. So a is 0 means b also will be 0, and we found only 2b, sorry, this will be 4a 2b plus c. 4a plus 2b plus c will be equal to 1. 4a plus 2b plus c will be equal to 1, as a 0, b 0, c we found 1. So here from these two examples, we found only c term will be 1 and other terms will be 0. Likewise for this case, a b c d will be cancelled out and only one it will be 1. So 1 by this one will be come up at last, and the answer will be e to the minus 2t into t to the 4 by 4 factorial by using fast shifting theorem. Fast shifting, shifting fast shifting theorem, what we have been already done. Okay, now we are going to go for the another question belongs to type 2. So here I am going to suggest to all of you that this question direct you have to solve by using this one, fast shifting theorem, whatever we already done. Okay, now consider this question. Find inverse Laplace transform of 1 by s plus 2 square into s minus 2. Here it is interesting that one term is not repeated but another term is repeated 2 times. So by considering partial fraction for this one, here you can write this repeated term can be written as a by s plus 2 plus b by s plus 2 square plus this is c by s minus 2, right? You just add it, it will be a into s plus 2 into s minus 2 plus b into s minus 2, okay, plus c into s plus 2 square, c into s plus 2 square divided by s plus 2 square into s minus 2. You just solve the numerator, we can found a into s square minus 4. If I will multiply this plus bs into bs minus 2b plus c into s plus 2 square means this one, right? So just multiply a square minus 4a plus bs minus 2b plus ca square plus 2cs plus 4c whole divided by these two terms, 2a square plus s plus 2 whole square plus s minus 2. If denominator of LHS and RHS is same, obviously the coefficient of a square, as and constant has to same. Okay, so that means here coefficient of a square is your a plus c, but there is no s square term in your LHS. So a plus c will be equal to 0 because there is no a square term is there. Likewise, s term we cannot found in the numerator of your LHS. So here b plus c, b plus 4c, coefficient of s will be equal to 0. Then constant is your minus 4a minus 2b plus 4c will be equal to how much? Will be equal to 1. That we have to write minus 4a minus 2b plus 4c equal to 1. Okay. Now here a is your minus c. So here we have to put instead of a is your minus c, it will be 4c minus 2b plus 4c equal to 1. So this will be minus 2b plus 8c, 8c equal to 1. Okay. And if I am going to add this one, b plus 4c, b plus 4c equal to 0 by multiplying with 2. You just multiply 2 with this equation, 2b plus 8c, 2b plus 8c equal to 0. So if I will add these two, then we can found this can cancel out, 2b minus 2b plus 2b, this is 16c equal to 1. So we can found c equal to 1 by 16. As a equal to minus c, so a will be minus a by 16. And b will be equal to, here you just put instead of c equal to 1 by 16, so we found b will be minus 1 by 4. Now we are going to consider inverse Laplace transform of this and this side by substituting the values of a, b and c. You just substitute the values of a, b, c and consider the inverse Laplace transform. So here we have to put instead of a as 1 by 16 minus 1 by 16. Here I substituted minus 1 by 16 into 1 by s plus 2, 1 by s plus 2. Then b is your minus 1 by 4, 1 by s plus 2 square plus c is your 1 by 16, c is your 1 by 16 into 1 by s minus 2, 1 by s minus 2. So here minus 1 by 16 already is there, minus 1 by 16. So this is nothing but s minus of minus 2 will be e to the minus 2t minus 1 by 4 already there. So here you can see 1 by s square, if it will be there 1 by s square, then inverse Laplace transform of 1 by s square will be t, but here s plus 2, that means s minus of minus 2 is there, so e to the minus 2t will be multiplied, t into e to the minus 2t plus 1 by 16, this will be e to the minus 2t. Finally we found e to the 2t. Here you can see plus 1 by 16, no, this one plus 1 by 16 e to the 2t written over here. Then then 1 by 16 minus 1 by 16 taken common from these two terms, we found minus 1 by 16 into e to the minus 2t, e to the minus 2t taken common from these two terms, we found 1 by 16 minus 1 by 16 into e to the minus 2t into, this is your 4t plus 1. This will be your answer, right? So here we have to stop our discussion today. In our next class we are going to discuss question and answer belongs to type 3 and type 4. Okay, so thank you so much for watching this video. Thank you.